So assalamualaikum and good day, welcome back to my video. So you are here again for this time. So in the previous video I have already shown you how we can construct this ultrasonic circuits, which is basically just by using these 4 ports only. 2 ports will goes to the digital ports, and then we have the power supply and ground. And then I also have explained how to explain the basic concepts of the HC-SR04 here, or the ultrasonic sensors here. And then I also have shown how to use or how to construct the circuits in the Proteus, and how to load the library files from different sources into the Proteus so that you can use it with your circuits here. And then I also have shown you how to install the library for this ultrasonic sensors, and you can use it in this tutorial here. So this is what we have covered, or what I have explained in the previous video. So if you want to know more on the basic concept of the ultrasonic and you don't watch the previous video yet, so please watch the previous video first before you proceed with this video, because this video I will no longer explain about these circuits. I will no longer explain how you can load the library files and how to download the library files. Everything is in the previous video. You can go to the previous video by click the link up top and or just click the link down below. So please watch that video first before you proceed with this video. In this video I will directly go to the coding as usual. So let's move on to the coding. So how we can code our ultrasonic sensors. So basically we know that in the previous video I have already mentioned that we have these 2 pins here, the trigger and echo. So we need to tell the Arduino where is the echo and where is the trigger. So now the trigger is at the pin 3, the echo is at the pin 2. So basically we just define echo pin, or whatever value you want to give that. So echo pin at the pin 2. So we need to tell the echo pin at the pin 2. So this is basically to tell the pin D2 for the Arduino as echo 2. So that's it. So this is basically the first one, attach pin D2 Arduino to pin echo of HC-SR04. And next we go to the we define where is the trigger pin. So the trigger pin or trig pin is at the pin 3. So remember again, it is at the pin 3. So the pin 3 here, so the trigger pin is at the pin 3. So therefore we put the pin 3 here, which is basically the pin 3 is the trigger of the HC-SR04. So that's it. That is the first thing we need to tell the Arduino where we put the we connect the echo and where we connect the trigger. And after that we start to define the durations and distance, because we want to know basically we want to know the duration, the time, and also the distance. We want to calculate the distance since there are division here, and it use a floating number here, or the decimal places here. So therefore we need to define it as long or float. So here maybe I just use long so that it can decimal places can go a longer decimal places than the floating point, then the float library. So that's why I use long here. So long for the duration. So this is for the duration of the sound wave. And then we have again the distance. So distance, maybe you can define it as integer, or you can define it as include if you want to get in the floating number or the decimal places. So here I just use distance in integer so that I don't have floating points, just exact number. So this is basically for the distance measurement. So again, this is what we do first. This is what we define first, and then now the definition is complete. Let's move to the void setup. So in the void setup, we, as usual, we tell that the pin mode for the trig pin here and the echo pin is output. So the trig pin is at the pin 3 as output. So since trigger, it will trigger the sound. So the trigger the signal, as we can see here. So the trigger, it will trigger the signal, and it is an output. So therefore it is an output. So now we define it as output so that it trigger the sound, and then echo is listen back. So echo is listen back, meaning that it will become the input to the Arduino. So this is why we use this as the pin mode for the echo pin. So input, so as input, and again we want to display the distance by using the serial monitor. So if you want to use the serial monitor, as usual, just serial.begin. So serial.begin with the 9600 of baud rate. So that's it. This is again as for the serial monitor, initialize serial monitor. So that's it. That's the only pass for the setup. Now we move to the void loop. So now this is the function that will will keep repeating. So again, what I mentioned in the previous video, so if we look at this, what happens here, trigger will become high for about 10 microseconds. So it will goes high for 10 microseconds. So it will become active for 10 microseconds, and therefore what we do to make it high, as usual, just using digital write, as usual. So trig pin with the high value, so we trigger it high for about 10 microseconds. So since delay, if you use delay is in milliseconds, so delay is in milliseconds. If you put 1, it is in milliseconds. So if we want to use microseconds, so you can use delay microsecond, delay microseconds, delay microseconds, again for the 10 microsecond. So delay for 10 microsecond, and then it will goes back to low. So it will goes back to low after 10 microsecond. So therefore we just digital write again for with low value. So this is to trigger the sound, and then next, after it trigger the sound, what it needs to listen back to the sound, So here what it does to listen back to the sound, what we need to know is basically it will get the duration of the high of the echo value. So in other words, what we do here, this is a new lines of codes, or the new knowledge for you, the new coding that is never used in the previous video, which we will use. Now we want to know duration that we define above here. So this where do we define duration, which is equals to, so this new coding here is pulse in, the pulse in from the echo pin that we defined previously. So it will receive from the echo pin, which is high, because it goes high for a certain amount of time. so we check how long it goes high. So that amount of time that it goes high, then we can calculate the distance. So therefore calculate the distance. So to calculate the distance, we just use distance. Remember back from the previous video, so distance is equals to 0.034 times t over 2, times t over 2. T here is the duration, so t is the duration, meaning that what we do here is equals to duration times 0.034 over 2. So that's it. So this is from the previous video, 0.034 times t, and that's how we calculate the distance. And as usual, after calculate, we want to verify the value is correct. So let's display it, display the distance in the serial monitor. So basically, as usual, for this part here is similar like before. We just use the serial.print. So just use serial.print and then distance, and then serial.print the value of the distance, and again in centimeter. So if you want to have space, so put a space here and put a space here. Make sure you if the sentence you need to put the quotation marks there, but for the values you don't need to put the quotation marks, and then print line so that it goes to the next line. So this one will be displayed in one line, and then it will goes to the next line. So that's it. I think that's it. Yeah. So this is the lines for the void loop. So if you miss any parts, just look at this codes here. This is the lines for the void loop. So again, you may pause this video anytime if you think this video is too fast. If it is too slow, you can increase the speed of this video. But this is the only codings for this pass here. So it triggers high for 10 microseconds, then it goes back to low. It wait for the pulse in from the echo pin, and then you change it into the distance, the durations based on the duration value by using the formula that I showed in the previous video, and then we display it. So that's it. That's how we do it. That's how the codings are. So as usual, let's verify this coding and connect our Arduino to the computer so that we can test it, test the coding. Okay, done compiling. So as usual, let's check first. It must be Arduino Uno. If you use Arduino Uno, if you use other Arduino, make sure you use the correct Arduino, and then the COM ports, and then we upload the codings, and let's try to check the video. Alright, so done uploading. So now let's try to check the values here. As usual, if you want to watch it in the serial monitor, click this value here. So it detects the values at 37. So let's say I put my hand here. So my hand here is at 16. So it should display 16 as you see here. When I move closer, now it is at 12 centimeters. So 12 centimeter correct. I move closer, now it is at the 8 centimeter. So 8 centimeter correct. So this is how you verify, and make sure you verify with a ruler here so that you can see the values is correct. This is how we done any testing. We need to verify. We don't again, we don't do short sendiri stuff, and we don't do something that we just assume yeah it's correct, but we don't retest it. We don't see clearly the values with the the actual rulers, the actual scales, and therefore I show you here. If I put my hand at the 15 centimeter, the value at the serial monitor should also show the correct value. So meaning that the formula is correct. As you can see, the formula is correct. The coding is correct, and yeah, that's it. That's how you do that. Not much of a challenge, I think. It's just a simple coding, and I think that's it. Basically, that is the only parts for ultrasonic. Not much, just this part only. If you face any difficulties, this is, I show you again, this is the coding. So this is the how you define the echo and trigger, and then for this void setup is nothing different. Now we move to the void loop. So void loop, again we have the trigger parts, and then the echo parts, and then the calculation parts. Yeah, so that's it. Yeah, so as usual, if you have, or if you try to run your coding into the Tinkercad, so just use the same coding and click play button. So now when you run your codes, yeah, with the same coding, so it shows the value here. So how to change the value from the Tinkercad? So just basically just click on the ultrasonic sensor and just adjust this balls here, so it will come out the value. If the formula is correct, the value shows in the serial monitor, and the value shows in this part here, it should be similar or almost similar. So that's it. That's how we try by using this Tinkercad. And for those who use the Proteus, since we only use this potentiometer, let me show you. As usual, we goes to export compile binary, and then done compiling, we goes to the Proteus, load our ultrasonic. So again, your file, your hex file, so make sure it is the correct hex file. Okay, but the first thing that you need to know, basically we need to double click on this ultrasonic sensor. Before we move further, make sure you click this twice, yeah, and then you need to search for the hex file, the ultrasonic sensor hex file that is shown previously. So let me open again, 70 open archive. So basically we have this .lib and .ids, but we also have this hex file which we already transfer it into the library file. So again, navigate into the library. So navigate into the library directory. So again, where you save your library, so basically the library should be, if you use the default directory, so it should be in program data, lab center electronic, Proteus 8 library. So you should find this hex file, ultrasonic tab.hex. So make sure you load this first so that it can run. If you don't load it, then it can't run. So that's it. Now everything is ready. Let's try it. Alright, so now it comes with this value here, but as you can see, if I change this potentiometer values up to 0, so it goes to 4 centimeter, but it is too sensitive, because the values is, as you can see here, although it just at 9%, is already at 103 centimeter. It is too sensitive, and therefore we need to adjust a little bit the coding, so that it meets the usage. Let's say maybe you need to divide by 6, maybe I try. So let's say we try to use 6 here. So So done compiling. Let's try to run again. So now it is nicer than before. But it still goes too high, but it is acceptable. Therefore, this is how you try using the ultrasonic sensor in the Proteus. So basically, this is how you change the distance in the Proteus. So that's why you might need to change a little bit the coding, like I've shown just now. Maybe you need to divide by 6 to make it more accurate and more realistic to the real ultrasonic. But again, the real ultrasonic sensor, you can't use over 6, you need to use over 2, divide by 2. So that's why usually I not really recommend using simulation only. The best thing is you try using the real hardware. If you can get the real hardware, please get the real hardware and try it by yourself. That is the best way to test any hardware, to develop any hardware development skills. And I think that's it. I think I did not miss anything. If let's say if I miss anything, as usual, tell me in the comment down below. If you have any questions, any problems, as usual, also you can just directly ask me within the message or just comment down below. And like always, if you like this video, please leave the thumbs up button down below. And if you want to know more about Arduino or about electronics in general, feel free to consider yourself subscribing to this video, or maybe share this video with someone else that you think need this kind of informations. And that's it from me for this time around. I hope this video helps. Hope this video answering all the questions related to the ultrasonic sensor. And again, as usual, stay safe, stay curious, and stay joyful. I'm Ikhwan. May God bless you. Assalamualaikum.